we're trying to follow along with ALX copyright instructions. So we seem to have not a full house yet, but still we have some people here with us. So let's just quickly say hi. We don't have the chance to interact each time we are connected via YouTube to ALX. So but now we have the chance. So it's not about one person, it's about all of us. We're here to learn together. So hello everyone, you're free to unmute.
Hi, good evening.
Hello, good evening, Emmanuel. Okay, this is your first time joining us, yeah?
Yeah.
Yeah. Welcome. So hello.
Yeah, hello, good evening.
Good evening, classy.
Yeah, good evening.
Hello.
Good evening.
Hello, seniors. Hope you are doing well.
Yes, sir. Doing well.
I see, I don't know if Clarkson is around, but looks like I don't see him around. But anyway, like I was saying, it's going to be Q&A session, not specific questions anyway. Not talking about the exact task that we are supposed to solve, but the topics in general, how you can think about the problem and how you can solve them. So that it's not like we are answering the question for you, but then you're going to get the muscle memory to be able to solve them for yourself, which is very important. So while we are with him, we could still maybe share our grievances, what has been causing the problem.
Yeah, I'm back here. Thank you very much.
Great.
My network, it's been really hard. So were you in the middle of discussing something? I didn't interrupt.
Oh, we're actually waiting for you. I was saying that maybe we could start with discussing what hasn't been going well, or what is grieving us, or maybe how the how the whole thing is going up until this point.
Yeah, exactly. That's my plan as well. So yeah, just like the lazy programmer said, like we said initially, it's sort of like a discussion segment, a Q&A. We just try to tackle questions you might have. Don't ask the exact question on your internet account, please. Do not ask us, or do not post your question and say, I'm trying to solve this particular question and you expect an answer. No. The way it works is that if you do not understand the topic in general, the topic or an example of that question, you can give us an example of that question, or you can explain. I think everyone here understands what I'm trying to say. Do not tell us the exact question you're having problems with. You can tell us the topic and we'll be free to shed some light on it, but not the exact question. Okay. So yeah, at this point we can all, just like lazy programmer said, does anyone here have any questions in regards to any question at all in regards to their journey with ALX these past few days? I think let's take it one at a time. Let's start with the first person on the list. That would be Royal. Royal, do you have any questions? Or
Good evening, everyone.
good evening, Royal.
Okay. I'm just up my head around the pseudocode. If you can just throw more light on that for me, please.
Pseudocode.
In general.
Okay, what are pseudocodes? Okay. Maxwell, I think you'll be able to handle this one, right?
Hello, did you hear me?
Okay. All right.
Yes,
We
we
heard
heard.
you. Okay, so you were asking for maybe a general overview of the pseudocode, right? So I think I'll throw it back to you and then ask you a question. If I ask you to make a tea for me, how do you go about doing that? Royal, right? Royal.
Rhea, can you
Can you
hear
hear
us?
me?
I couldn't hear the last person speaking. It's a bit too fast.
Oh, sorry. If you can hear me now, I'm asking. So you're asking about, or you are asking that we expand on what it means by pseudocode. So I just wanted to throw the question back to you and ask, if I asked you to make a tea for me or for yourself, what are the steps that you're going to use to make the tea, or how would you generally go about making tea?
Okay, if I'm asked to make a tea for myself, I would first of all put water into a kettle, boil it, pour it into a teacup, and then put in my tea before I pour in the water.
Okay, so that's nice. So that means every time you need to make tea, that's the same process you go through, right?
Yes.
Okay. So right now you just explain how you make your tea, and that isn't like the steps that you're giving us. And then this step that you're giving us is not the actual tea that you just made. It is the process you use to make the tea. Right. So these are the steps, or let's say your recipe for making your tea. So when we talk
Yes.
about the pseudocode, it's not real code. It is just like the pseudo in the pseudocode means fake. So it's not actual code. It's just normal language, plain language, like the one we are speaking now, that we use to make or to explain what we are trying to do step by step. And that brings about the concept of algorithm. So the pseudocode helps us to explain what our algorithm is. And the algorithm just stands for, or to make it simple, it's your step-by-step process, just like you mentioned how you make a tea. Okay, so that's basically what the pseudocode is all about. It's you telling us step by step how you are going to make something, right? So, if that makes sense.
Okay.
Yeah. So, and basically that's a pseudocode, but then maybe when it comes to programming, that's when maybe we think it is something out of the ordinary, but then it's basically the same thing. So the same way you're able to make your tea, you know how to make a tea, or you know what a tea is. So you know how to do it. So if you don't know what a program is asking you to do, or what the requirement of a program is, then you can't basically write the steps. If I ask you to make a dish you don't know how to, you would have to figure out what it is before you can start even listing out the steps you would use to do that thing. Right. I hope like these scenarios are like fairly relatable.
Yeah, they are. But in regards to just like you said, in programming, it's a bit difficult trying to put those things to play out to make sense. That's what I really would want you to probably
Okay,
use an
I didn't.
example.
Okay, sorry about that. So I wasn't saying that in programming it wouldn't make sense. I'm saying that the same way that if you don't know how to make a dish, you can't tell the steps. It's the same way that if you have a program, if you actually write a program and you don't know the steps, you can't write down the pseudocode. Or if you don't know what the program is supposed to do, you can't tell us how you are going about it, right? So yesterday we were using a very general example of a voting app. We are going to ask the user how old they are. Then we check whether they are old enough to vote or not. It was established that the voting age in most countries were 18. So we said that after we receive the age of the person, we check it whether they are 18 years and above. Then we tell them that yes, they can vote, else they can't vote. So this is our algorithm for the voting app that I just mentioned. Right. So let's take an example again. Let's say that we are trying to see whether we are to go or to pick an umbrella or not. So let's say when we are going out and then we look at the weather, right? So if the weather seems very cloudy, we may be inclined to pick an umbrella. If it is not, then we will not pick an umbrella. So these are not, but let's say like very much more generalized, and they are depending on the things that we do. Maybe another one more is how you take pictures with your phone, right? So if you don't mind, could you maybe take us through how you would take a picture with your phone? You can tell us what phone it is, or you can tell us how to generally you would take a picture with a phone.
Sorry, please, can you come again with the question? I didn't quite get you.
Okay, so I'm asking that you take us through how you would take a picture with your phone, right? Maybe, if possible, how do we take a portrait picture with their phone?
A portrait picture. Okay. Yes. I'll first of all go to my camera, and then I would go to the portrait. There's a portrait segment. Click on the portrait and then take a picture.
Great. So you see that there's a clear start and there's a clear end, and then in between there's what you do. So okay. That is the pseudocode thing, like your steps. Like your pseudocode is the thing that you are using to explain your algorithm, right? So let's this not maybe confuse anyone. You see, the algorithm is the main thing we are trying to explain, and we use the pseudocode as a means to explain it. And as you can see on the screen, it says that a pseudocode is an informal way of programming description that does not require any strict programming language syntax or underlying technology considerations. It is used for creating an outline or a rough draft of a program. Right? So it is not necessarily like code. It is not even code at all. It's just something that we write to make it easier for ourselves to understand how the program is going to be run. Like the way you just explain how you would take a picture with a phone. Right? So this is how you would explain to someone the way to take a picture with a phone. Okay. So what I was trying to drive at is that the same way that you need to know how to do something before you can explain the steps, you would have to be able to understand what the program's requirements are before you can write out the pseudocode, which explains the algorithm. Does that make sense?
Yeah, it does. I understand that. Thank you.
Right. Okay. Okay, so are there any more?
Another view of all that was said is that yeah. Maxwell, I say something.
Oh no, please go ahead. Go ahead.
Okay. So yeah, basically, sorry about that. Basically, pseudocode is just like a way of drafting or a way of outlining the steps taken to achieve a particular task, or just like you giving a list of the steps you take to accomplish it. It's just like a visual aid, something to help you to better understand your algorithm or better understand how your program will be implemented. So that's just it.
All right, thank you.
Yeah, no problem. So you don't need to worry yourself about the name pseudocode. What are pseudocode? Are they a type of code or program language? No, it's just the name. No, nothing like no codes are involved, just your normal English language and the steps. All the steps you just listed, how to create how to take a portrait picture and stuff like that. All of those are pseudocode. So we do them every
Okay.
day. Yeah. All right. So more questions. Okay. Let's go over to. Sorry if I don't pronounce your name correctly. Okay. Is it? I can't even pronounce this. Ni 30. Is it Ni 30? Can you hear us? Okay, let's move
Yeah,
on.
I can hear you.
Okay, yeah. So, do you have any questions or anything concerning ALX so far?
No one at the moment.
So you understand every single thing you are doing at ALX?
No. I really don't understand everything. I mean, I just joined the group, so like I'm kind of lost. Like how what you guys are discussing. Hello, can you hear me?
Yeah, that's what we're asking.
Oh,
Okay. Yeah. So basically, we're talking about steps, not steps, right? We're talking about it's more like a Q&A session, okay? We're just discussing, talking about questions and answers, how our journey with ALX has been so far these past few days. So everyone is sharing their inputs because obviously we've started doing projects. So everyone is sharing their inputs, their questions, and they're getting response and answers to their questions in general. So are you stuck in any project currently? So let's start with
yeah.
that.
Currently, I'm stuck on the pseudocode project, the flowcharts and the others. I'm
Okay, it
working
seems
on one currently.
a lot of us are stuck in the pseudocode aspect. So basically,
Yeah,
that's your
yeah. For now, that's the only thing.
okay. Okay. So pseudocodes, Marshall has just explained that. Unfortunately, you missed it. It's literally on the screen right now. So I think we haven't
Yeah,
talked
I
more
can see
about
it.
it. We just talked about a general idea how it works. Okay. I think lazy programmer, I think we're going to delve deeper. What do you think into pseudocodes?
Yeah, well, I mean, we all know pseudocodes, but then when we talk about it in the software engineering side, that's where maybe people think it is different. But everything that we've been talking about now, like the process we use to do these things, anything that you can think about, how you even batch your routine, like how you go about tasks. Yeah, so I think we can take on tasks, maybe pick a task that is relatable to maybe most of us, and then we can see or like list out the exact process that we would use to do that. Then we will do it. Right.
I have
Yeah.
a
So
question. Good evening.
yeah, good evening, Precious. Please go ahead with your question.
All right. So, after this probation period, when we start the tax that will be graded for the checker, will it keep giving us the errors till we get it right, or it will just score us with our errors? I don't know if you get my question.
I think you are asking an ALX related question, like question meant for the instructors at ALX, because we're not instructors, we're just normal students like you. So this is my first course, so I don't really have much information on that, so I'm not in a position to give an answer to your question. Maxwell, do you have an answer?
Well, I could help a bit. So, from what was given, it said that like during the probation, yes, I mean the checker will still be there to check the code, right? But then what will happen is just that currently when the checker gives you an error, it tells you what the error is. But then going forward, that feature is going to be taken away. That is what I have read. So that is you see that even when the checker shows you an error, it tells you to use it with reason. Like when you are checking the reason why the error is there, it tells you that use this with reason. So after some time, it's like that feature that tells you what is wrong will go away, and you have to figure out what the bug is yourself. So the checker will still be there to check the code. That's how the code to be checked. But the details about why the error came is what I think will be taken away after some time.
Wow.
Yeah, do you understand that? Thank you once again.
Yeah, I do.
Okay. So pseudocode. More. I just remembered something concerning this. Pseudocode is not exactly a problem. Okay, pseudocode is, if you can think about it, you can literally write it or write the pseudocode. What's more of a problem is flowcharts. Yes, I believe that is a problem. Getting familiar with the diagrams, and you don't think that you just have to learn it for the sake of ALX. You're not going to come across it when you start working. Of course, every programmer writes a flowchart. It's basically a way of structuring or of showing how your program works or summarizing a program's flow. Yeah, so there are some specific diagrams you use to represent certain operations like start, input, processing. So there are certain stuff like that. You need to familiarize yourself with that. So it will help you in creating a better, well designed flowchart. Maxwell, is it possible to show us your? Nah, that would be a copyright infringement. I would have used yours as
What?
as an example. Your flowchart, the one you did for ALX.
Oh, I mean, we could work through something else. But the other issue is the microphone, remember? Yeah, that's the other issue.
Yeah. That's true. That's true. Yeah.
Yeah.
So I wanted to show an example. Okay, let me see if I can get a rough sketch from is it draw.io? Yeah. I think
Yeah. So
I think I still have my my flow chart. Very
yeah,
first one I did.
if you have any desk, I can connect to your PC from here, and then that way I can also be working from that side, if that's possible. So you
Okay,
can,
yeah.
I mean,
Okay, yeah. I have an index actually. Well, I think
okay.
I think I have access to the very first one I did.
Okay.
It's not nice, it's not pretty, but I think it's like a graphical representation of what we're trying to talk about. So this is an example of a flow chart, like we all are familiar with now. So basically, it's actually okay. Okay. So this is just for explanation. I won't go into the details of where I got the question from. So now again, you can see the directions, and it's not pretty. Okay, it's not pretty. The reason why I wanted to use Maxwell's was because his was more detailed and structured, better structured. So, but since we're just doing this out of the box, we're just going to talk a bit about these shapes here and what they all mean. You can see the direction, the flow of the program, and why exactly is it flowing like this? Why is it taking this structure? Uh, it's highly unlikely to have two separate people working at two separate computers at different locations to come up with the same exact flow chart. Of course, it will be similar, but it will not be identical. There will be slight or major variations between the two. There will be some differences between the two. So again, the way I design this flow chart will be absolutely different from the way someone else will. design this flowchart. So theirs might take a less number of steps. Mine might actually take more number of steps. So it just depends on the individual. So you do not have to think that your flowchart, because I saw someone replied to your message on WhatsApp, lazy programmer. He said that your flowchart has been copied. So just copied the design or the way it's going to be structured. So it's not, there's no specific structure. There's no specific structure on how a flowchart should look, but it has to follow the steps. It has to be organized. So you don't, obviously you can't have end here. Let me see if I can zoom. Okay, yeah, I can. So obviously, you can't have end here, which is the end of the program. You can't have it at the top here, which is start. So obviously, it follows a course of action. So you have start, inputs, read, and then we'll come to a decision. You have to make a decision, and then you see these arrows pointing and directing. Okay, so we're going to talk about all of this in a bit. Just give us a general idea of what all of these mean, so that they won't look cryptic to us anymore. So Maxwell, can you just handle like the first 2 or 3 shapes there? Yeah, I think 3, the first 3. Or should I go ahead and start?
Yeah, you could. Maybe, like I was saying, if you could, so that I could show my mouse on it, or maybe when I say you could show your mouse on that as well. Like in the case of you maybe sharing your screen for me through any desk or any remote software, that, yeah. But anyway, okay, let's see what we can do. So normally I've seen that there are multiple ways to start something, but I think we can maybe start with a problem, then we can work our way through an accepted pseudocode, then we implement it with the flowchart. Through that side, then we can talk more about what the shapes are doing, so that like when we
okay, so basically we should create
we
just create a new problem and then get the flowchart to work with it, right?
Yeah, sure. So
okay.
What I'm thinking about is, well, so we can do like is one very popular question, or let's say, yeah, I think so. To do the sum of n number of natural numbers, right?
Yeah.
So let's say we are supposed to add 1, 2, 3, 4, 5, 6, 7. Like maybe the user will enter something like number 10. So you add 1 to 10, or if the user enters 50, you add 1 to 50. So we are trying to get the sum of the first n number, or the first n natural numbers, right? So which is something very popular that maybe we all can work through. I mean, this is something that we have. So I would explain what it is doing, then we see how we can come about with pseudocode, as in what you would think about it. So like just the way we did yesterday, don't try to maybe like think about the exact method. You mention anything that you think should be part of it, then after we are done, we can start putting them together. Right. In the meantime, maybe you can pass through the back end and send me your ID. Okay. Passing.
Okay, we'll do. So yeah. Maxwell, why don't you go ahead and do that while I quickly run some stuffs in the back end and
sure. Okay. Right. So we can have a quick chat about it. So the problem is adding a sum of n natural numbers. Right? So natural numbers are basically, if we should explain, or I mean, if anyone wants to explain what natural numbers are, please can you so that it is more interactive. Who can maybe tell us what natural numbers are? If you are inclined to Google, please Google.
It is allowed.
Say again.
It is allowed. You are free to Google.
Yeah. All right. So
Direct
yeah,
respond. The
sure.
natural numbers are like numbers that are increased by one, I think, and they can be negative, just like consecutive numbers, right? Abi?
Okay.
They are
Okay.
non-decimal numbers, like numbers that do not have a number, like 1, 2, or -1, -2.
Please, can you come again? I didn't hear you well.
Okay, I was saying that natural numbers are numbers that don't have, like, non-decimal numbers, like they increase by 1, like he said, like
Yeah.
1, 2, or -1, -2. So they don't have like a decimal part. For example,
Oh,
1.02 is not a natural number.
okay. So that means natural numbers can be negative or positive. That's what you mean.
Yeah, I guess.
Yes. Okay. Anyone else is what it said? I mean, we can be checking ourselves. I mean, yeah. Let's see, because natural numbers.
Well, Max, so I sent it to
Right.
you.
Okay.
So yeah. Anyone else want to tell us what natural numbers are?
Actually, I just checked. They say that natural numbers start from 0.
Exactly.
Negative numbers cannot be natural numbers.
Good. So that was how I was saying that Google is allowed. Yeah. So I was just waiting for maybe someone to just Google and tell us that, oh, hey, I found this on Google, please. Just don't be so much bothered about Googling, right? It's a very important skill. So okay, now that we know that natural numbers are numbers that start from 0 to infinity, right? So we can say that they are, let's say, positive whole numbers, right? We can say something like that because, like you said, they are non-decimals. So, and they are also non-negatives because they start from 0, and 0 is neither positive nor negative. So we get that part. Okay. So now that I am connected, we can work through the pseudocode about how we would solve this problem. So we all will brainstorm together, and then we'll come up with an answer. All right. Okay. So let's start to do some brainstorming session. All right. All right. So what do you think we should do? We are trying to have the user give us a number. Then from the number that they'll give us, we will add all the way from 1 till the number, as in to get the sum. So for example, if the user gives us 1, we will only do 1. If they give us number 2, you do 1 plus the 2, right? Then if they give us, let's say, 3, you do 1 plus 2 plus 3, right? So you see how like the thing is going. So let's say if let's say n equals 3. Oops, I can't see. I can't. Okay. So if n equals 3, then it's going to be 1 plus 2 plus 3, and that's going to give us what, please? That's going to give us 6, right? Yeah. So in the same way,
Six.
if the great. In the same way, if n is 5, then that means it's going to be 1 plus 2 plus 3 plus 4 plus 5, which is going to give us, what's the answer for this one?
15.
15, right? So we see the way that the program is supposed to go. So we are trying to think about how the program is going to work. So this is how it is supposed to work. So when the user gives us a number, we want to add add from 1 to the number. So if they give us 100, that means we are going to do 1 plus 1 plus 2 plus 3 plus 4 all the way over there. So think about this maybe mathematically or any way that you can think about it. But the bottom line is that we are going to think about how we are going to solve this problem. So please, what do you think is one of the steps that is going to happen? It doesn't have to be the first or the last or anything. It can be anywhere within. What do you think should happen? Like this program, we are trying to get a number or like the sum of n natural numbers. So we've explained what natural numbers are. They are numbers that start from 0 to infinity. So let's see how we can go about that. Anyone with the first step?
I think that the first thing to do is to create a loop for loop, right?
Come again to do what?
The first thing to do is to create a for loop.
To create a for loop. Okay, so maybe someone. Okay, that's fine.
Yeah.
We'll come back to explain
before we have to.
Okay.
Okay.
Yeah, I'm listening.
I was saying that before the for loop, we have to initiate the number first. The number of, the number that we have to stop at.
Okay, so initiate the, or let's say initialize rather, so that it sounds initialize the.
That's true.
The what?
The number to stop at.
The number to stop at. Okay.
That comes behind the for loop. I mean, you have to get the number first before starting the for loop.
Sure. So currently, what I'm trying to do is like we're just listing out the steps, not in any particular order at this moment, but I'll put it on top anyway. I think Clarkson's network is giving me trouble. Okay, please more. Okay, so we can create a for loop, which we would explain what it is soon, and then we're also supposed to initialize the number to stop at. Okay, so any more suggestions? What can we do?
I should probably create an empty, an empty variable to carry the sum.
Yeah, sorry about that. My network was really bad.
Oh, yeah. You're saying we should create an empty variable to do something.
Yeah, to carry the sum of all numbers, like to increment it every time that we get a new number.
Okay, so something like the sum.
Yeah, let's call it sum.
Right, great. I'm waiting for access. So, okay, we have to create something and like initialize a variable and call it sum. Okay, so currently we can create a for loop. We're also thinking about.
Actually, you haven't sent a request.
Okay. All right. Let me do that. Okay, so one step is to initialize an empty variable, or the variable that we will stop at, or the number that we stop at. We also have the sum, which is going to be updated every time that we get a new number, right? Or every time that we go through whatever we are supposed to do. And then what's the next thing? Okay.
I think the next thing is to work the for loop, like to get inside the for loop and start the incrementation.
Okay, so you say that start the for loop, and begin incrementation.
Yes.
Okay. Okay, so I mean, this discussion is for all of us, please. So, what does someone else think? Are these steps going to be okay for us to do the work, or what does anyone else think? I see lots of people here. This problem has been broken down into, let's say, a very simple problem. So let's all try. The one that you have, let's have it. Let's all talk about it. Israel, what do you think we should do? Okafo, what do you think we can do? And I'm seeing your name on there on the on this side, so please, what are we supposed to do? Like, what is your thought process? What can we do?
Sorry, I just entered. I didn't get the question.
Oh, okay. Sorry about that. So we are trying to do write a program that sums the number of natural numbers that we receive. So so we are trying to see that how or what processes are going to make this possible. So we established that natural numbers are numbers that start from 0 and they are positive whole numbers, so from 0 to infinity. So when we are asked to sum natural numbers, we start from 1 to the number that we receive. So for instance, we are saying that if the number or the natural number that we are supposed to sum it up is 3, that's going to be 1 plus 2 plus 3. If it was 5, it's going to be 1 plus 2 plus 3 plus 4 plus 5. So basically, when we are adding the sum of natural numbers, we start from 1 all the way to the number that was given. Right. So a little bit background on what we are doing. Hopefully that gives you an idea. And we are asking, what do you think is one method or one process that we should do, or one step that we can do that can help us get this goal? It doesn't have to be the first or the second. Anything that you think can help with this particular task. What do you think should be done?
Hi, Marcel.
Yeah.
So at some point, I think there should be the step where you add inputs.
Add input.
Yeah.
If you could rephrase that, it'd be very nice.
Like get input of numbers from the user.
Amazing.
Sorry, someone having dinner. Save some for me, please.
All right. So, okay, great. So,
Right.
all right. So, at some point, we get input from the user, right? Okay. So, the thing here is that we are trying to make things easier for ourselves by thinking through the whole process first before we get started. You see, because I see that sometimes we always want to try to start from the top, which is maybe good. But then sometimes the first step doesn't come to you right on the spot. So you can start by writing all the jumbled thoughts that come inside. Then you can look at the options that you have now, and then you can now see that since that you now have the pieces, now you can puzzle the thing together, right? So we have an option to create a for loop, another option to initialize a number to stop at, initialize sum to 0. We start the for loop and begin incrementation, and then also we get input from the user, right? So which other methods do you think we should use, or are these methods enough now? Can we go about ordering the steps in the way that they have to go? Maybe 1, we do this, 2, we do this, 3, we do that. Does anyone have anything else to share before we continue? Or any questions?
I just think there is one step that we can omit. We
Right.
get from user, because actually we get the number to stop at, so we can start the for loop from 0 to that number, so we don't have to get input from the user.
Oh, okay, good.
Yeah, that's a
Fine.
fine suggestion.
Yeah. See that we are trying to get the sum of n natural numbers, so the input has to come from somewhere. If we take the input from, if we hard code the natural number, that means that every time the program is going to do this, it's going to be static. So I would suggest that we take the input from the user so that the program can be dynamic. Is that okay?
Okay, so in interactive way.
Yeah.
All right.
Clark, I think I lost it again. I'm coming again. Okay, so now that we have these steps, let's see how we can write it back in ordered steps, how we are going to go about it from one step to the other, so that we can be sure that our program is going to run the way that we want it to run. Then we can draw the flowchart from that side. Okay, so now let's go about writing the actual steps that we're going to use. So we can see the ordered steps. So here now we go from 1 to wherever it is. So now we can see the options that we have over here, right? So to create a for loop, to initialize the number to stop at, initialize sum to 0, start the for loop and begin incrementation, and then get input from user. I think when the sum thing was mentioned, he also mentioned that we should update sum every time, let's say, a value is encountered. Okay, so something like that, right? But now we are going to think about how we are going to write this in much more succinct words or sentences, and then we will use the same way to do the flowchart, right? And if there's time, we can even write out a program to see how it is working, to confirm that yes, our algorithm is working, our pseudocode checks out, our flowcharts make sense, and the code proves that, right? So now let's go through. The number of time that we would take to do this will determine whether we will do any of the other two. So please, let's start talking. Which of these steps should be the first one? I'll give you the first one. It's to start. So please, no one should tell me to start the program. I've already started the program.
Wait, I thought that comes that's the last step.
Say again.
I was just joking. I said that this would be the last step.
Okay.
That's the last step.
Oh, I also know that last step that is end. So you can save yourself on that one. I've helped you on that particular part. So at this point, we are looking for the magic that happens in between. Right, so let's demystify the magic. Right. So let's see. So the program has started. What's the first thing that we do before anything else?
I think that should be initialize, create a for loop. So after you start, you create the loop.
Okay. After we start, we create the loop. Okay. Anyone else? And please mind you,
Get
the
the
great. Please continue.
from the user, or get the value from the user.
Okay, get the value from the user. Okay, so I'll come back here and then ask you why you like what you said what you said. Okay, so Zoba, why do you think we should create the for loop first? Why do you think we should create the for loop first?
Zoba is silent.
Or maybe Israel, right? You can tell us why you want us to get input from the user right after we start the program.
I don't know. I think maybe the input from the user will also determine how the loop, how many times the program will loop, because maybe it will be used for the incrementation. I don't know, just something like that.
Okay, so okay, fine, that's good. So what if I ask you why you would put on like you put the water on fire or put the water in the kettle to heat before you would even put the like do anything else whilst I'm making tea, right? So there's a very particular reason, right? Because if we can't be sure about our algorithm, then we are not sure about how it's going to run, right? So that's one thing that maybe we've not mentioned. But then every algorithm has a clear start and it has a clear end, and it has a result that can be known, right? So we should be able to predict what this is going to do. So the moment we can't do that, then our algorithm is, let's say, not very tight like that. All right. So maybe you can sit back again and then come back with an explanation, or anyone else can also help us with that. Why do you think we should create or get the input from the user before we do anything else? I see T-Tech, I see Dan, I see Precious. Do I see Vanessa? I see a lot of people. Royale, Kuro, Emmanuel, Samtiro, Chris, everyone say something. Okay, so the more you voice it out, the more you get to understand it.
Usually a Q&A, like a discussion segment. So it's only if we give our inputs and we give our inputs, that is the only way we can, learn from each other. It's not about one person speaking and speaking, or two people talking and talking and talking. No. If you don't understand what we're just doing, just tell us we don't understand, or I don't understand from the very beginning. Okay, it's fine. So it's not strict. It's flexible. So you can say what's on your mind.
Right. Yeah. So what he said. So it's supposed to be interactive, and also, please, you see, when you start doing these things, when the project starts coming, you can also voice out your opinions when you are working with your peers. Because if you do not do that, you'll be one person that no one wants to work with, because you won't bring inputs. When you're talking, you keep quiet. And people are looking at this within this session, so don't think people are not watching. If people are looking at people who are talking, and they will come to you when they need something. But then the moment they see that you don't say anything, like, maybe it's I don't know whether it is a safety mechanism so that they won't bombard you with questions or anything like that. But please, let's talk. There's a safe space. Let's mention why we think things
Sorry.
are the way that they have to be. Yeah.
Sorry,
Please
I was not saying anything. I was actually in a noisy place, so I could not talk. So,
Okay.
from what I understand, from here, I think you said you should create a program that we sum n number of integers, right? Some
Right.
n natural numbers.
Yes.
So I don't think there's a reason to create a loop, because so let's say we want to use just three natural numbers. You can just, what you did there, if n equals 3, so we can just let's say ask user for for numbers, for the three numbers to use. Then you can just sum the three numbers. Or am I the one not getting the question right? Because from what I'm seeing here, I don't think there's any reason for a loop. So that's
No.
just my take.
Okay. So we are not asking for the user for a loop. We are asking the user for a natural number, right? So we are going to sort of, okay. So we are receiving an input, right? So we are going to receive a whole number, a natural number from the user, and then we will add that. We will take that number. Let's say the user enters 3, right? So the n of n natural numbers, which is 3, start from 1 all the way to 3. So that is the 1 plus 2 plus 3, right? So how we are going to implement the program or the algorithm to do this is what we are looking at. So if we are to get 3 separate numbers, that's going to be a problem. So the program works by accepting one positive integer, which is a number, of course. And then from that number, we are going to start from 1 and sum up all the natural numbers up to that number. Okay, so that's what the whole program is about.
Okay, I get you. We're asking the user for the numbers, to user to input the numbers. Okay, fine. So let's say for example, we ask user to input 3 numbers. We have our number. We have our numbers already, and what the algorithm want us to do, what they want us to do actually is just to calculate sum. So I don't think there's any reason for a long process. What I'm saying, if it's sum we are calculating, now we have our user have inputted 3 numbers already. I think what we have to do is just go on and sum up the number, then print output. That's what I think. Hello, can you still hear me?
Yeah, we can
Can I
hear
say
you.
something?
Yeah.
All right.
Did you hear what I just? Did you hear what I
Since
just said?
we
I think
to
Maxwell, we lost the connection with Maxwell. Yeah, please go ahead.
Okay. No, I already said what I wanted to say.
Maxwell, are you with us?
Yeah, I just came back.
Okay.
Okay, so I see that maybe you have an understanding of your own, which is driving where you are attacking from, right? So if we take two numbers, then, I mean, I'm not saying any of the things you are saying is wrong. Neither am I saying is correct. So far as it answers the question, it is correct. So far as your algorithm checks out, we are good to go. But here, what the question is actually asking us to do, maybe I've not written it out in, let's say, more a conc something, but sometimes this is all you have. Write the algorithm to calculate the sum of n natural numbers. I think maybe the question, let's say, it's a little ambiguous, but
Can I say something?
let me try again. Yeah, please continue.
I think why we should get the input from the user is because it's going to be used in the condition of the loop. That is, if we are going to be using loop.
Right. Okay. So I'm not trying to get us to maybe agree on that. Okay, so this is what we are doing, and that is what we actually understand and why we are doing it. So, for instance, you are saying that it is because you are going to use it in the condition of the for loop, right, or in the loop, right? So, anyone else with a different reason or any other thoughts?
I think that does not justify why it should be first. Like, it can be second or third. The important thing is that it's before the for loop. Since we're going to use it in the for loop, so it has to be before that, but it doesn't have to be first.
Right. So then what can, yeah, so I mean, at this point, we are putting out our steps. So what should be number 2 after the program has started? So the moment the user clicks and opens the program, what is the first thing that they do? Or what is the first thing that we show them?
The initialization. Initialize the sum.
Initialize the sum to 0. All right. Is that fine by everyone, or any other reason, or why do you think? I mean, you see, that like the whole reason why we are doing this is so that you get to start thinking about the problem. Right? So if you're waiting for the solution, we will give it to you, but then you would understand. That's the thing. So there are multiple ways to answer this same question. We'll see that as well. Okay, so we initialize sum to 0. Oops. Okay, so number 3, then what's the next thing that we will do? We've started a program, we've initialized our sum to 0. Okay, then what next?
I'm thinking up the number third step should be allow input from user.
Okay, allow input from user. Okay. We can say get input from user. And then we can make sure that it is an integer, right? Because we said that the natural numbers are numbers that start from 0 all the way to infinity, right? So then after we get the number from the user, what's the next logical step? I mean, you see, we already have the some of the step here. So if you think any of the step here should be part of the main steps, you can just point it out, and then we would go from there. That is why we talked about it before we started this thing, right? So after we get the input from the user, what do we do?
Yeah, Maxwell anymore.
You can hear me.
Okay, yes, we can. Yeah.
Yeah. So I was asking that after we've taken the input from the user, what is the next thing that we do?
I think we create a for loop.
Okay, so we create a for loop, and why are we creating a for loop?
Can we say that getting input from the user is the same as initializing the number to stop at, because we're going to assign that input to that to the number as a variable, and that variable is the number to stop at. Is that correct?
Yeah, we can say that. Like you see that when you say yeah, we can put that in 2 steps if that's what you want. And then here it is implicit that if we get the input from the user, then we are basically going to store it somewhere, right?
Yes.
Yeah. So
question.
yeah, maybe in your implementation, you can say that initialize the number to stop at, right? So if you say that one, you can explain further by what you mean by that, which you just said. But then in the pseudocode, we are trying to be very succinct as much as possible, right? So even for this one, I'm adding some details over here to maybe more explain it, but then we could have done away with them, right? So some of the steps over there, we can pull them together and write them as one sentence without doing 2 steps. Are we okay?
No, I have a question.
Okay.
What we're collecting from the user, is it still the same sum that we're working with?
Come again.
It's a
What?
different variable. The value we're collecting from the user, is it a different variable from the sum that we're using?
Yes. Yeah. So sum is a different number altogether, and the number we are getting is different. So we are getting the number which we would use to get our sum, right? Right. It's like getting A and B or X and Y, and then adding it to sum, right? Or getting the results from doing X plus Y or A plus B, and then the sum is the result.
It's the output.
Makes sense. I mean, that's how we are talking about it. I'm not trying to make a definite statement that this is what we do, right? I'm trying to get you to talk. So what you think is, so like you tell us why you think this should be the thing, and then you can explain why you think so. Then we can go from there, right? So this is not me telling you that this is it is it. I can take whatever you say and I'll write it. When we do it and it is wrong, then we can figure it out. If it is right, that's fine. But let's not be so strict to maybe find the right thing at this point, right? So unless you've been doing this for a long time, you're not going to get it very good at the first time, right? So bring out all the things in your head. It doesn't have to necessarily make sense. Yeah, let's just bring them out.
So just a quick one. Sorry. Does everyone understand what we're trying to do so far? I just want to see if we're all following. So it doesn't seem like we're just explaining and it seems we're just doing something that seems impossible to do. Of course, we're getting some valuable input from everyone here, but we just want to know, is everyone following? Does everyone understand what we're doing here? Or is this just wasting of data? Because there are some videos or there are some sessions you join, you think, I just waste my data, or I'm just wasting my data. So, like, you,
Yeah, I
you,
do. I
you,
do understand.
I do understand.
okay. So our engagement is very much appreciated. Let us try to engage, even though we don't know the answer, but let's engage. Let's try to make it interactive so we all can enjoy.
Oh, it's actually helpful.
Okay.
I'm not sure I understand very well. I'm just trying to follow through.
Okay, for
Okay.
me, it's almost like I'm going through all of this for the first time because I just joined the program. But this is actually very clear. I'm getting it, even though I don't know what steps to take, but I'm understanding it step by step.
Okay.
Just using math knowledge to look at it. Aside that, I think I'm very much lost.
Yeah, so these are the kind of inputs we are looking to hear so that we can know where to go. Because if there's no input, we are not able to understand whether we push forward or we come back a step so that we can see where we go from there. And then from the things everyone is saying at this point, looks like we are all on course and we understand what is happening, just that we are not saying it. Okay. So if that's the case, then um, I would like you to not worry about, or you don't have to use technical terms. Think about the thing. Maybe you can say, go on, or you get here, then you stop. It's accepted. Just say it the way that you would do it. You see how maybe when you're telling someone to cook something, maybe you can say, stir until you see this, or do this until you see that, or when you're giving someone a direction, go until you see this signpost and then you turn left or right. If you don't see that, then turn the other way. Or if you go and then you see the lady who sells this, you turn the other way. Like that kind of thing. Like we read, it is not a formal language. It is more of an informal thing. So we just have to push it out. Let it come. Right. So we've started the program, we've initialized a sum to 0. So basically we are saying sum is equal to 0 because currently we don't know what the total is, right? So that's the sum. And then we are going to get input from the user. So you see that when you are opening something, let's say when you open your Facebook account or your Twitter account or something, they ask you to input your username and your password. That is an input that Twitter or Facebook has given you. So after you input your username and password, then Twitter will check whether it is correct before it will even give you access into into your account. So think about that process as like that pseudocode we are doing. You open twitter.com, you enter your username and password. If it is correct, you are accepted into you are logged in. If it is not correct, you are prompted to enter the password again. So it keeps on doing this until you have the password correct. So this is, let's say, something that we do all the time. But then when we start to break this down, that is when we get to see how the thing works. So that is all we are trying to do here. So now with that aside, let's come back to our pseudocode. And mind, we are still trying to draw out this thing. So let's make it quick so that we can see how we can implement that in the flowchart. Right. So and the input is going to come from you, like the answers are going to come from you. So yes, let's go. I've already said mine. I said that we start and then we end. I've given 2 things. Who amongst you has given 2 things so far? Just me. So please.
That was helpful.
Yeah.
He gave the 2 common thing. I said he gave 2 things.
Yeah, I've done 2 things.
I think we all gave the two things.
Yeah, so let's all also give two things. Yes, let's go. I mean, I've given three
I
things.
think the next step will be to check if the input is a natural number.
Okay, so we check if the input is a natural number. Okay, so then I can not do this one here. So you see that currently I wrote here that the number must be a positive integer. So you see that you are saying that we should check if number is natural number. Okay. So we start the program, we initialize it. Sorry, we set 0 to 0. So maybe if the initialize is very new, is the same as, let's say, set something, set this to that, right? So let's say set z sum to 0, right? And then we get input from the user, and then we check if number is a natural number. If I can type correctly, natural. That's how it's very natural, right? Or wait, why is it doing something on my eyes?
This is correct.
Really? Okay.
This is
Sometimes you write some things and then it looks some way. Okay, fine. Thank you. Okay, so we've gotten these steps so far. What will be the next step? So we check if the number is that, and then so the one who said check if the number is a natural number. Can you help us with exactly how we check if it's a natural number?
We can use the if else statement to check if it is a natural number.
Yeah, so exactly how do we check? How do we know? If what? If what? Else what? I mean, anyone else can
we see something like
answer this question.
Can we see something like this? If number is if it is natural number, then add to previous sum, else prompt user for another number. Maybe, I'm not sure though.
Okay, good. So now I want us to know, like, do something. We have something here that says check if natural, like the number is natural number, and you also mentioned that we should check if the number is a natural number. Then we add it to the sum. But then, how do we know it's a natural number? We have already explained what natural numbers are. So
we say if the number is superior than 0 and if number is integer.
Okay, so you can see that if the number is greater than or equal to, because we said that they start from 0 to infinity.
Yeah, 0
right?
being
or start from 1. You can choose that, right? So we can start from 1 if you want to, but sometimes they say that it start from 0. So that's fine. So that means if number is greater than or equal to 0, clock. I lost it again.
And
okay, so if
integer.
yeah, so if I think I lost access to the screen. Okay, so yes, if the number is greater or equal to 0, then we can assume that it is natural number, and then also it must also not have decimal points, right? It must be a positive integer, right?
Yes, and can we say if number is integer? I mean, is there a syntax to say that? Is it a right syntax?
Yeah, right. Yeah, in the higher level languages, we can see that. But yeah, we can say that there's pseudocode, right? So we can say if number is integer to make things simpler. Yeah. So we could make it much shorter and simpler by just saying if number is integer. But I've lost access to the screen though, so we can still talk about it. So if number is integer, we do something. Okay. So now, what is the next thing that we would have to do? We've checked if the number is this or something. We do something. If it is not, then we do something else. Okay. So if number is integer, what next?
I think now is when we start the for loop.
Then we start the for loop. Okay. So we start the for loop, and then anyway, what's the for loop?
Maxwell, can you hear me? Just a quick one. Sorry for cutting you short on Tarek. I think we should divide this session into two parts. Like now we have the first part, and obviously we should have a second part where we further complete this particular question or this particular session. So because it's already way past our time. Well, we're riding on extra time. This is 26 minutes extra. So I was thinking tomorrow is Monday actually. We can have the part 2 of this session tomorrow, and then we'll have part 1 today. So part 1 of this session will be uploaded to the YouTube channel on this group, while the part 2 of this session will be uploaded to another YouTube channel. We'll drop the link to that YouTube channel in a bit. So I think it will work that way. Maxwell, what do you think?
Oh, okay. So yeah, maybe having the session where we talk about it, then the session where we implement it. Yeah, I mean,
It's sort of like we continue from here.
Yeah. So, and hopefully, maybe in that other session, we talk more because of the not talking, that's what is dragging the whole thing. Because if we like give the input, maybe I don't understand or I don't think something, right? So instead of not saying anything, you can be like, okay, I get it, but I don't know exactly how to say it. So maybe I'll come back again, right? So that kind of input would help to make things much better. Okay, so we could finish up this one though.
Yeah, we could. Just sorry, let me share my screen. Okay.
All right. Okay, so looks like still not have access. Clark, are you here? I think maybe on that side going again. Oh no. Okay, folks, I think he's experiencing very bad network today. But okay, we check if the number is an integer, then we started the for loop, or we are to start the for loop. So I was asking Tariq, correct, right? Tariq, what is the for loop and why do we need to use it?
The for loop is so that we do not have to write the same instruction more than once. So We only write one instruction that repeats itself.
Right. Okay, that's great. So hopefully everyone understand that. So the for loop is to help us not to repeat ourselves. Okay, so that we can do one thing over and over again with short instruction. Okay. So now what do we do in this for loop, or in this loop, so that we don't have to maybe let's not we can say loop, but not let's put the for aspects down for now, so that we can try to take it away from programming as much as possible. Okay, so now the screen is back. So let's say so we're saying that if the number is an integer, or say positive integer, right? So we are assuming that if the number is a positive, right? Sometimes you say something and then you write something else. So we check if number is a natural number by making sure that the number is a positive integer, right? Then
Can I ask a question, please?
sure.
Okay, because I'm just following, I would just like to ask, when we started, it was clear that we're working with natural numbers, which means it's going to be a positive number. So what's the need to check if the number is a natural number, if the number is a positive integer, when that's what we're working with?
Okay, great. That's a good question.
Is it a possibility that it could be a negativity, like negative 0 point something?
Maxwell, can I take this?
Sure. Okay. So you see, when we are running programs, right, we can't trust the users to do the right thing. So we have to ensure that they are doing the right thing. Okay. So in our minds, we know that the user has to enter this. I mean, if every user was like that, every programming job would have been so easy. But we can't trust users to enter exactly what we are asking them to enter. So we have to make the extra check to see that they are actually being obedient, right? So that is why we need to check and confirm. So like the program is asking us to implement that algorithm. So we are also going to make sure that the user doesn't enter something else that they are not supposed to enter. But this is our implementation of it. You can have a different one which doesn't check it. Right. So if yours doesn't check it, it doesn't mean it is wrong. But this is an extra step to ensure that the program doesn't break. Right. So that you see that sometimes when you are accessing something and then you type in the wrong inputs, it beeps out to you and then gives you the chance to redo what you are doing. Right. No, you are supposed to do. So that is why we are checking to ensure that we are really getting a natural number or a positive number, because the user can enter anything else. Users are very notorious, I must tell you.
Okay, thank you very much.
Sure. Okay, so with that out of the way, we say that we are going into the for loop, so, or into a loop, and we understand what a loop is now. So in this loop, what do we do? So we enter into a loop, and why are we entering into the loop? Right. So we now understand what a loop is, and we see that. So why are we trying to do something over and over again? If this helps, remember that when the n, which is the input that the user will give us, is 3, we do 1 plus 2 plus 3, which gives us our answer. Then if if n is 5, the result is going to be 1 plus 2 plus 3 plus 4 plus 5. So you see that for the first time when n was 3, we did the 3 steps. When n is 5, we do 5 steps. When n is 10, we're going to do 10 steps. So that means that we are going to write out 1 plus 2 plus 3 plus 4. Right? So what the loop is helping us to do is so that we don't have to do this then ourselves in the code by doing maybe 1 plus 2 plus 3, like that we are doing it by hand over here. So the loop helps us to do this automatically by continuously updating the sum with the next number. Right? So hopefully that is giving you some information on what to say.
Yeah, that's understood.
Okay, so then
Question.
okay.
Sorry. From the step 4, check if number is a natural number. If number is a positive integer, I think there is supposed to be something should happen. Not, I think we are missing something.
Yeah.
So we
So
just skip.
then yeah, that's when we enter the loop over here.
Loop.
Thanks for pointing that out.
Okay.
Okay. Are we okay?
Yep.
All right. So we enter into a loop, then we do what? Like this is the part that we are interested in. And once we do this part, we should be done with a pseudocode because we've initialized sum to 0. We've gotten the input from the user. We've checked whether it is a natural number, which is a natural number if it is a positive integer per our algorithm. So now that it is, we've gotten all the things that we want or we need for the program. Now we are supposed to get the sum, right? So now there's a hint. So we are entering the loop so that we will get the sum. So what is going to happen is that we are going to go from 1 to the number that we received, like I said in the beginning. But whenever we get a number, we are always going to start from 1 to the number that we received. So that is why I'm saying that like the natural numbers, sometimes they say that it starts from 0, but mostly we can just start with 1. Okay, so
can we do the opposite, like start from that number and decrease the number until we reach 0?
I'll have to. I think I'll have to stop recording now because my laptop's about to die. I have 19%. So, which is why I said it would be better if we just have this first session and then have another session to quickly follow.
Okay. So I guess maybe then we would have to maybe if you could send this to the group so that maybe you can continue from where we ended today. Like do that as let's say homework or something, maybe to complete the pseudocode, and then next time when we meet, we can see what we were able to come up with. Also go about to see how other ways we can go about solving this particular problem. So I think we would have to meet another time since his machine is going down, right? So but then if you guys want, maybe we can talk about it after this, but then I'm seeing that it's getting late at different places in the world. So we can as well maybe have this session another time. What do you guys think?
Fine by me.
I thought you had mentioned another class tomorrow, another session tomorrow. That would be nice too.
All right. Okay. So for the reason that the laptop would go up, and then if it goes up, then that's going to be a very, a very bad problem or a very bad thing. So we would end today, and the issue has not been solved yet. So please don't go and relax on it. See how you can complete it. Either take a screenshot or he will try. He will send it into the group for where we got into, and then you can try to continue from that side. Try to do it, and then when we meet tomorrow, then we can talk about it. Right? So later, after the deadline of the project we are doing, then we can talk about all the projects that we did, the flowcharts, the emails, everything, right, together, and you see how everything is. So let's come back with information. Okay, so if there are a few questions, we can take it and then we will call it night from where I am coming from.
Okay, I'm back. So sorry. I keep having network issues today. It's really terrible.
Mm-hmm.
Yeah. Okay.
Okay.
We're still talking. Let me screen share. And let me stop the recording. So I'm ending the recording here, but we can still continue our conversations.